Video 78 then, looking at number patterns. Why are number patterns important? Well, in algebra and a lot of mathematical programming and science, there are patterns that come up in numbers that we have to be able to recognize. For instance, I've been making a computer program on a chessboard, and it has to turn coordinates into a number of the square, and to do that I had to recognize a number pattern between coordinates that were picked and which number of the square it was. I could then convert that into an algebraic equation. So that's an example of where I had to be able to recognize number patterns, and I could apply them. Number patterns that you have to recognize can be addition, subtraction, odds, evens, multiplication, division, multiples, and powers. Now, all of these we've heard of, but how do we recognize them when we find a sequence of numbers? So in the example of addition, here we've got a sequence -5, -2, 1, 4, 7, and so on. The first thing I'm going to do is look at the difference between the first two numbers. In this case, the difference between -2 and -5 is 3, because -5 add 3 is -2. And I always look at the second two numbers as well. It's important not to miss the first one. We'll see why in a second. And the difference of this between -2 and 1 is 3. So therefore, the amount that we're going up by is staying the same. It's 3 every time, and it's addition. So we can simply say that we are adding 3 to the previous term. So you might be asked in an exam, what's the next number? In which case we'd add 3 onto the 7 to give us 10. Or they might say, well, what's the rule that decides the next number? And in this case, it would be adding 3 to the previous term. And remember as well, odds and evens go up in twos. So you can use this trick to see if it's a pattern of odd numbers or a pattern of even numbers. If it's going up in twos and the first number is odd, then it's a pattern of odd numbers. If it's the first number is even and it's going up in twos, then it's a sequence of even numbers. So subtraction, then here we've got 9, 4, -1, -6, -11. When I look at the difference here, the difference between 9 and 4 is 5. 9 take away 5 is 4. And I look at the second difference, from 4 to -1 is 5, and it's 4 minus 5, not add 5. So we can definitely see here that we are subtracting 5 from the previous term. I looked at the difference again between the first two sets of numbers, but I could see that in one I'm adding it on because the number is getting bigger, and in the other one I'm taking it away. So the rule is we are subtracting 5 from the previous term. Let's have a look at this then. 2, 4, 8, 16, 32. Well, if I look at the difference between the two first of all, because that's what we've always got to do with sequences, the difference between 2 and 4 is 2. I look at the next difference, the difference between 4 and 8 is 4. So we've got a problem here. We are not adding or subtracting. So we can first of all rule out this rule of simply adding or subtracting an equal amount. I'd next try dividing 4 by 2. So 4 divided by 2 is 2. And then 8 by 4, 8 divided by 4 is 2. So now we're suddenly seeing a pattern. When we divide the second one by the first one, we always get 2. In other words, we're multiplying the previous term by 2 to get the next term. So when we were on 2, we multiplied it by 2 to get 4. 4 multiplied by 2 is 8. 8 times 2 is 16, and so forth. So you're multiplying the last term by 2. We can also have division. So in this case, 27, 9, 3, and 1/3. Like before, we look at the difference in the first one, 16, and the difference between the second two is 6. So we're not adding or subtracting. It's not a fixed amount that it's going down by. We're going to 9 this time is smaller than 27, so actually the value is decreasing. So it can't be multiplication, because multiplication would increase the amount. But I'll still carry out with that. 27 divided by the second one is 3, and 9 divided by 3 divided by 1, or 9 divided by 3 is 3. So we can see a pattern now emerging that we are dividing the previous number by 3 to get the next number. 27 divided by 3 is 9, 9 divided by 3 is 3, and so on. So we can look at the difference and see whether it's going up or down at a fixed amount to see whether it's addition or subtraction. And we can divide by the smaller number of the pair to see if there's a fixed amount we're multiplying or dividing by. And obviously if it's multiplying, the number would be getting bigger. If it's dividing, the number would be getting smaller. We can also have powers. So here we got 8, 27 and 64. Well, 8 plus 19 is 27 and 27 plus 37 is 64. So the differences aren't of a fixed amount, so we can rule out addition and subtraction, I should say, sorry. And then 27 divided by 8 is 3.75 and 64 divided by 27 is 2.37. So not a fixed amount that we're getting by when we multiply or divide, so it's not multiplication or division. Therefore, we must be working with a power. Now, there are other patterns in numbers, and when we deal with the nth term, that will come about. But in this case of simple number patterns, we won't have to do that. So to work out whether it's a power, I start with the square root. So I square the 8, 2.83, square 27, 5.2, not square numbers. Then I use the cube root. So the cube root of 8 is 2, the cube root of 27 is 3, the cube root of 64 is 4, and we can see a definite pattern emerging here. The numbers are simply, the cube root of the numbers are simply increasing by 1. So let's have a look at another example where we've got 2, 4, 16, 64. The differences aren't the same. 4 minus 2 is 2, 16 minus 4, so we're not dealing with addition and subtraction. Dividing 4 by 2 gives us 2, and 16 divided by 2 gives us 8, not the same number. So 16 divided by 4, that should say, sorry, gives us 4. So they're not giving us the same number when we multiply or divide. So we know we're working with squares. So we try the square numbers. So the square root of 2 is 1.41. The square root of 4 is 2. So they're not square numbers. Cube root of 2 is 1.73 and the cube root of 4 is 1.32. So we're not dealing with cube numbers. We've run out of options here. So in an exam, you probably wouldn't, it's unlikely that it'll be the 4th root or the 5th root. So instead, move on to then try squaring that number. So 2 squared is 4, which is the next number. 4 squared is 16, which is the next number. Right, the previous number is being squared. So that gives us our last type of pattern that we can see. So have a look for if the difference is the same, then it's addition or subtraction. If dividing gets us the same number, then it's multiplication or division, depending on whether it's going up. Then try out square roots, cube roots, and try out square roots, squares and cubes to find which number pattern is being followed.